Hello again. Today we're going to do Chapter 4 on financial markets. Before we get started onto, we're going to do money demand and money supply, put them together into a model, look at interest rate determination, look at how the price of bonds and the interest rate are inversely related, things like that. But before we start, let's just make sure we're all on the same page with regard to terminology. So there's three different concepts in economics we need to keep separate: wealth, income, and money. And in common usage, people use the word money for all three. So they'll say, that person makes a lot of money. What they really mean is that person has a lot of income. Or they'll say, that person has a lot of money. What they really mean is they're wealthy. They have a lot of stocks and bonds and houses and all the things that you add up to get a person's wealth. But in common usage, money is used for all three. When we say money, we're going to mean something very specific. Now, the definition of money varies a little bit, and we'll go through that later. There's an M1 definition and M2. But when we talk about money, we mean the stuff you can use to go to the store and buy something. So you can use your checking account at the store to buy goods and services. You can use currency at the store to buy goods and services. You can't use your savings account. Now, maybe you want to count that as part of a broader definition of money. That's a discussion we can have later. But for us, money is just going to be currency plus what we call demand deposits. And demand deposits are checking accounts. And so everything in your checking account plus all the coin and currency that you're carrying, those two things together constitute what we mean by M. So it's not wealth and it's not income. Okay, now we're going to focus on financial wealth. So we can take financial wealth and we can divide it into two components: money and bonds. So B will be bonds and M will be money. And what distinguishes these two things are bonds are all of the interest-bearing assets out there. These pay interest, either explicitly or implicitly. There's some rate of return. So even stocks would be in here because there's a rate of return on those stocks that you can call the yield, and that's what we mean by interest. Bonds would be in here, commercial paper, money market accounts, all sorts of financial assets. We're collecting them into a single aggregate. Again, we're aggregating, and we're just calling it bonds. And the concept there is these are things where you could put your money where you would earn a return. Money, on the other hand, pays no interest. Now, that used to be literally true if part of your money, remember this is currency plus demand deposits. Checking accounts, demand deposits do pay a tiny bit of interest. That's easy to incorporate here. What we really mean is the difference between these two. So your checking account might pay, a really small amount of interest, but if you were to put it into a government bond or a corporate bond, you'd make a lot more. So there's a big spread here between these interest-bearing assets and non-interest-bearing. The other thing that's different about these is that these are more liquid. And by liquidity, we mean the ease of converting things into cash, because how liquid something is tells you how easy it is to use that to buy something. Money is perfectly liquid, bonds are not. And so you can't use a treasury bill to go buy a car with. You have to first convert it to cash. Now those are highly liquid, that's not hard. Some corporate bonds, though, if you get stuck with them, nobody will want to buy them. There are some corporate bonds that don't trade at all on any given day. Lots of them don't. And so those might not be quite as liquid as say, a T-bill, a government bond backed by the government. If you have some doubt about the future of that company, you might get stuck with a corporate bond and not be able to sell it to anyone, at least not at a price you're willing to take. And so there can be differences in the liquidity across these things. But anyway, so we're separating it into these two things: the highly liquid, perfectly liquid money that you can use to buy goods and services, and all the other financial assets that are a little bit less liquid, depending on what they are, and they pay interest. Now, we want to look at what Keynes called liquidity preference. Later, we'll use the symbol L to stand for liquidity preference, which is another name for money demand. So what we're trying to ask is, okay, look, these things pay a lot more interest. This doesn't pay any interest at all, or a very tiny amount. Why would you ever put any money in here when you could earn a lot more money by having it in bonds? And the answer is, well, I need to carry some money around to buy goods and services with. I need some liquidity because if I see something I want to buy, I want to be able to buy it without having to go through a lot of rigmarole, converting a corporate bond back into cash or something like that. And so so we're trying to figure out, okay, what is the liquidity preference? And the determining factor, a big determining factor here, is the interest rate, I. And what we're going to say is when the interest rate goes up, the interest rate, assume this pays zero interest, like the cash you're carrying around in your pocket. You don't get interest on that. The opportunity cost of holding $500 in your wallet is what you could make by putting it into, say, a money market account. It's the interest rate that you're giving up, the interest you're giving up by holding it as cash rather than as an interest-bearing asset. So the interest rate is the opportunity cost of holding money. And when the interest rate goes up, it's more costly to hold money. Money goes down, and bonds go up because you'll want to hold more money. I mean, think about it. If you had $100 in your pocket right now, and the interest rate was, it would never be this high. Well, I guess if you had hyperinflation, I guess you could get something like this. But say it was 100% per day, just as an outrageous example to make the point. Well, I could have, or you could have, whoever has the $100, could have put it in the bank this morning, and on the way home this evening, gotten $200. And so certainly in that kind of a case, you would really want to minimize the amount of cash you're holding in your pocket. Now, at really low rates of interest, it may not be worth it to you to make those kinds of transactions all the time. I mean, what you could do is you could put all your money into an interest-bearing account, a money market account, or maybe savings has a little bit higher interest, something. And then every time you get in the line at the store, at the checkout, let's say at the grocery store, you could pull out your cell phone or your iPad or something, and you could transfer money from your savings or your money market or wherever it happens to be into your checking account just in time to pay for the goods and services. And that would maximize your interest payments, because you'd have as much as possible into bonds at every point in time. But at a 100% interest rate or something like that, yeah, that might be worth it to do it. But at a really low interest rate, like it was during the financial crisis when it was nearly zero, it's maybe just not worth it to go to all that trouble and just leave all your money in checking. But as interest rates get higher and higher, say to 5%, 6%, 7%, people start getting much more careful about how they manage the split between what they're carrying around in their checking account or as cash and what they're leaving into other assets. And we expect as that interest rate goes up, they're going to economize on their money holdings because it's more costly. And so the first factor that we're interested in then for money demand is the rate of interest. As the rate of interest goes up, money demand goes down. So that's the first lesson here. Interest up, money demand goes down. So when the interest rate goes up, we ought to see money demand going down, because interest is the opportunity cost of holding money. Now, the other thing that money demand depends upon, money demand also depends upon the volume of transactions. And we mean the dollar volume here, the dollar amount that you spend each month. And the idea is that the more you spend, the more money you need to carry around to support those expenditures. And so someone who spends $3,000 a week is going to need to carry around a lot more money than someone who only spends $100 a week, just to support that higher volume of transactions. And we're going to capture the volume of transactions by income. Actually, nominal income. It's the dollar value of income. So we're going to say when income goes up, that's going to cause money demand to go up, because you need more. This is in the macroeconomy, this is the total amount of spending in a given period, like say a year. This is nominal GDP for a year. That's a measure of the total volume of goods and services that were purchased during the year. And the idea is a simple one. As that volume goes up, money demand's going to go up with it. So we're going to capture this then as saying, well, money demand is Py times this function L of I, where when I goes up, L goes down. That is, money demand goes down. Just like this is the liquidity preference part. That's why we have the L. So this is just that opportunity cost part. This should be down. I did that backwards. I may have said this before, but one of the problems with a video is sometimes you make typos on a board. A class will catch you. They'll say, "Did you mean? Is that what you meant?" I'll do my best to catch all those little typos on the board here, but I'm sure in the course of all these videos, one's going to slip through, and I'll just apologize in advance for that. I'll try. Anyway, so this is the money demand function. Here's the liquidity preference part. Here's the income part. What this is saying, suppose that you buy 100 things at $2, so nominal GDP is 200. This is saying that if you double the price to, say, $4, you're going to buy the same amount, still 100, but now they cost $4 instead of $2. You need twice as much money to do that. Alternatively, if you keep the price at $2 and raise this from 100 to 200, the idea is, well, we're buying twice as much, so again, we need twice as much money. So any change in nominal GDP, either because we're buying more stuff or it costs more, is going to cause money demand to go up 1-to-1 in percentage terms. Whereas the interest rate going up has a negative effect on money demand. Do people really behave like this, particularly this one, the interest rate? Is it really true that you reduce your money demand when the interest rate goes up a little bit? It depends on the interest rate. Again, we covered this before. But if you're a corporation who also has money demand and you've got $1 million, $2 million sitting in your checking account doing nothing, you're going to be very careful, even at low interest rates, to manage that money effectively. So if part of money demand comes from this, corporations holding money, they certainly behave this way, even at low interest rates. Individuals, at really low interest rates, there's probably not much of an effect here. But as the interest rate ratchets up to higher and higher values, then in fact, it's pretty reasonable to assume that people would behave in such a way. So again, that's going to be our money demand curve. Now, we can, if we want to, and we do this graphically. So what this looks like graphically, looks like I need to get a little darker pen here. Let me try another one. What we can do graphically is put the interest rate on this axis and M on this axis and graph the money demand curve. Well, it's pretty simple. Not necessarily linear, but it's MD equals PY L of I. So what this is saying, just what we've been saying all along, is that as the interest rate goes up, so there's money demand at that interest rate, as the interest rate goes up to I1, money demand will go down. And so we'd move from this point to this point. So this captures, the curve captures the L of I part. Then you could ask, well, what would happen if, say, PY were to change? So let's, what would happen then? And, well, let's think about it. Here's the function, MD equals PY L of I. Let's just hold I constant at, say, I1. So there's I1. So we're going to keep the interest rate at I1. No matter what now, I'm going to keep the interest rate at I1. If PY goes up with this fixed, what happens to money demand? Well, it has to go up too. So at the same interest rate, money demand would be higher. What if this was I0 instead of I1 and PY went up? Same thing. At the same interest rate, money demand would be higher. So what that tells us is that if either P or Y goes up, either individually or together, as long as the product goes up, then we know that money demand shifts out. So a change in I moves you along. Change in PY causes it to shift out. And presumably you saw something like that when you took your principles courses. All right. Let's now take a step towards determining what the interest rate will be in this model. So let's look at interest rate determination next. What we need to do is add a money supply curve. So we're going to start, as we said earlier, money equals currency plus demand deposits. Let's start very simply in a model with no banks at all, where all of the money is just currency, just to make it simple. And we're going to assume the Fed controls all of that. And we'll relax that in just a minute. We really, I guess, don't have to do it this way, but we're gonna start with this simple form. And if we assume then that the Fed can fully control the money supply, so this is the money supply, then the money supply will just be a vertical line in IM space. We're assuming that no matter what the interest rate is, the Fed can perfectly control the money supply. Doesn't matter what happens to I, they set the money supply at M, and that's what it is. It doesn't change. They control it perfectly. Now you just add in the money demand curve, the PY L of I function, and where those two things intersect, you have the equilibrium interest rate. So it's the intersection of money demand and money supply that gives us the equilibrium interest rate in this model. See that? Now let's look at how that interest rate might change and try to explain it intuitively. Something we're going to show a little bit later. I'd stop and do it now, but I don't want to break the flow. We're going to show, we will show soon, that the price of bonds and the interest rate are negatively, inversely related. That is, when the interest rate goes up, the price of bonds goes down, and vice versa. All right, and that, for the intuitive part of this, that's going to be important. So let's look first at what happens if the money supply goes up. And then after we do M, P, and Y and see how the equilibrium changes, we'll start looking at how the Fed actually controls the money supply. We'll add banks back into the picture, and we'll go through a little bit on the money supply. Before I forget, though, they actually formally derive a money multiplier in the book on pages 73 through 81. I'm going to skip those pages and just talk intuitively about what it does. I do that explicitly in gory detail when I do my money and banking class, monetary theory and policy, Econ 470. For this class, I just don't think we need to worry so much about exactly how those money multipliers are made, and so I'm going to do a very, we'll skip 73 to 81, and I'll do it much more intuitively. Just write down the result and try to explain it. Anyway, but that's what we'll do that soon. So we're not going to worry right now about how the Fed actually increases the money supply through open market operations, but rather simply talk about what happens if they do. So let's start off with the money supply at MS0, so, or M0, and let the Fed increase the money supply to M1. Actually, let me just index these. When that happens, we can see that the interest rate must fall to I1, right? That's the new equilibrium. But the question is, what's the intuition that gets us from this point to this point? And here's how it works. You start off here at equilibrium, all right? Then the interest rate is I0, and suddenly the money supply goes up. If the interest rate doesn't change, money supply will be greater than money demand. So at this point right here, money supply is greater than money demand at I0, right? You can see that. There's money demand at I0, there's money supply. Okay, good. Now what do people do with that extra money? They only want this much, and they've got this much. They've got extra money. There's an excess supply of money. We're going to assume what they do. Remember, we have this wealth. Financial wealth is money plus bonds. They take that extra money that they don't want to hold, and they buy financial assets with it. They buy money. So when the money supply goes up, money supply is greater than money demand at I0, and they use the extra money to buy bonds. So if the demand for bonds goes up, what happens to the price of bonds? The price of bonds goes up. And if the price of bonds goes up, according to this, which we'll show later, the interest rate must fall. A simpler intuition might be the following. So you come out to here initially, and then the interest rate starts falling as the price of bonds goes up until you hit this new equilibrium where people are holding exactly the amount of money that's out there. You have to lower the interest rate to get money demand to go up so people will hold that extra money. But initially, they try to put it into bonds. Now, what was I going to say? So that's the way you move from one equilibrium to the other. Good, good, good. Okay. What if P or Y, or PY as a product goes up? What if money demand shifts out? So let's start again with M and I. Money supply, money demand, which is PYL of I. Here's our initial interest rate. And for some reason, money demand suddenly goes up. So let's say that either P or Y goes up. Okay. For some reason, nominal GDP has gone up. Maybe there's inflation. So goods are costing more. Prices are rising. People say, uh-oh, prices are rising. Got to have more money. Or real income's going up. There's more stuff to buy, need more money. For either reason, money demand shifts out. Okay. Now again, at I0, money demand now is greater than money supply. That's just the opposite of what we had before. So remember that wealth, financial wealth, is M plus B. What they're going to do, they want more money than they have. Money demand is greater than money supply. So they're going to start selling their financial assets in order to get more money. So they'll move out of bonds and into money. As the demand for bonds goes down, people want less of them, or you can think of it as a supply going up. It's demand going down. As the demand goes down, what happens to the price of bonds? Well, when the demand for something falls, its price falls. But if the price of bonds is falling, the interest rate must be going up. And so you move out to here, and then as people start selling their bonds, the price of bonds rises, and the price of bonds falls, the interest rate rises, and you eventually get to this new equilibrium, I1. And so an increase in the money supply lowers the interest rate, An increase in P or Y raises the interest rate. And the reverse is true as well. Now, there's one more thing that explains money demand that the book leaves out. I think it shouldn't, because it was a key factor in explaining what happened to money demand in the financial crisis. Another thing that affects money demand is the risk of holding financial assets. You've got a bunch of wealth in financial assets, and suddenly you start get worried that they're risky, they might not pay off. The value might suddenly fall like it did in the financial crisis. If you start worrying that bonds are more and more risky, what are you going to do? Well, if you think the price is going to fall in the future, what should you do? Get out today. Maybe the price is 100 right now, and then it's going to fall to 50, you think. Well, you could get out today, wait for the price to fall, and then buy twice as many of the same bonds later on. That's exactly what you'd want to do. So when the riskiness of the financial sector begins to increase like it did in the financial crisis, money demand goes up. So we might say that money demand is P/Y L of I and sigma squared, where this stands for the risk of financial assets. And that's a positive relationship. When risk goes up, we expect money demand to go up. And that's exactly what happened in the financial crisis. Later on, when we have a more fully fleshed out model that we can use, we'll look at this. We'll say, okay, here's what happened. We had this big shock. Suddenly people got really, really, really worried, and they all dumped into money. Money demand went way up. And had the Fed not increased liquidity, that would have driven interest rates way up. And in the short run, it did. If you look at the federal funds rate, the rate that banks actually, that's the rate that the Fed actually targets. It's the rate that banks charge each other for reserves. Banks have required reserves. If you put $100 in your checking account, if the required reserve ratio is 10%, banks have to hold $10 in the safe, or they can deposit it with the Fed, but they have to keep $10 set aside. Some banks, at the end of the day, will be short of required reserves. Some will have too many required reserves. So there's a market called the federal funds market, where people with excess supply of reserves loan them to people who have an excess demand, who need reserves. And the rate they pay is called the federal funds rate. When the financial crisis hit, that federal funds rate began to spike upward. Now it's capped by the discount rate, the amount that banks can have to pay to get money from the Fed. We'll talk about these things later. But anyway, then the Fed immediately started increasing the money supply, bank reserves technically, the high-powered money we call it, and that kept that federal funds rate under control. But the point is, whether you got all those details or not is not important. The point is that when risk goes up, people get out of financial assets and they dump into money. And this is something we may need later, we will need later, in order to explain everything that happened during the financial crisis. So I just thought it was a good place to just point that out at this point. All right. Just graphically what happens is you have a money demand curve. Here's the interest rate. Here's M. When sigma squared goes up, this money demand curve shifts out. So when risk goes up, money demand shifts out. That's the point we're making. Having trouble finding a pen here that's dark enough. Let me try another one. Ooh, that's a little better. I've got 4 or 5 of them here I tested, and I can't seem to find. I guess the test was misleading or something. Actually, I use them for other lectures, so maybe they're just running out. Okay, now let's start looking at how the Fed actually changes the money supply. And they do that through something called open market operations. So the way the Fed, and you should know this from your other classes already, but the way the Fed changes the money supply is by buying and selling bonds on the open market in financial markets, and those are called open market operations. The Federal Reserve Bank of New York does these operations on Wall Street. So if the Fed wants the money supply to go up, what does it do? It goes out into the financial markets on Wall Street and it buys bonds. It usually buys treasury bills or treasury bonds. Treasury bills are short-term treasury notes. Treasury bonds are longer term. The word bond usually means long, and the bill usually means short-term, less than a year in maturity. But that's not important. They buy government bonds. During the financial crisis, they broadened that out a little bit and bought some other types of bonds. But during normal times, this is done almost exclusively through the buying and selling of treasury bills or treasury bonds. So if they want the money supply to go up, they tell the Federal Reserve Bank of New York to buy bonds. And they give them a quantity, or they give them an interest rate target we'll talk about later. So the bank goes out and it buys bonds from the public. Say it buys $1 million worth of bonds, and in return, it gives people $1 million. Now, it turns out the money supply is actually going to go up by more than that, that open market operation through something called the money multiplier. But we'll come to that in a second. If they want the money supply to go down, what do? In that case, they sell bonds. They say, oh, we've got all these bonds on our that we're holding inside the Fed, on our balance sheet, it's called. So what we're going to do is we're going to sell $1 million to the public. The public gives the Fed money, either checking accounts or currency. Usually they write a check. Doesn't make any difference. And that will cause the money supply to go down by more than the open market operation. So the equation that the book derives to explain this says the money supply is equal to, what do they use? I'm just going to say multiplier. The multiplier, they give a formula for this we're not going to worry about, times H. H is called high-powered money, hence the H. And it's equal to currency plus bank reserves. What the Fed actually controls with open market operations is this is also sometimes called the monetary base. Some books, like the book I use for monetary theory, puts an MB here for monetary base. High-powered money and the monetary base are the same thing. Sometimes they use the terms inside and outside money too, but I find that confusing, so I won't use those terms. Anyway, what the Fed actually controls through open market operations is H. You then hit H by this multiplier that I'll explain in a second, and that gives you the money supply. So if the money multiplier, this is a different multiplier than we worked out earlier. The expenditure multiplier was something else. In the goods market, this is the money multiplier. If this is, say, 2, which is not a bad estimate, might be a little higher, and this is 100, then the money supply would be 200. And so this is what the Fed controls. So if the multiplier is 2 and the Fed were to change this by 50, say they increase this by 50, what's going to happen to the money supply? Well, it's going to go up by 100. It's going to go up by more than the open market operation. And that's called a money multiplier. And again, we'll explain how that multiplier works in just a second. But let me also, one of the problems with this model is that multiplier is not a very stable number. It depends upon, this depends upon 3 things. Depends upon how much currency people hold, excess reserves held by banks, held by banks, and reserve requirements. We'll illustrate this one in a second, but the point I want to make is that during the financial crisis, the Fed did massive open market operations to try to get the money supply to go up. But the money supply, that should have been hugely inflationary. A lot of people thought, oh, if the Fed expanded the size of its balance sheet from about 700 to 800 billion to over 4 trillion. Okay, that's a huge increase. And that all came from these open market operations or something similar. So they created new reserves. This H, remember, is C plus R. It was almost all R that they created. So they created a huge new amount of bank reserves. What happened, though, was that those reserves never found their way out of the banking system. A lot of them just piled up in banks. If you look at excess reserves, I wish I had a graph of this. I should have brought one from the Federal Reserve data. During the financial crisis, excess reserves spiked. They went up by about as much as this went up. Not quite as much, but almost as much. So this goes up by many, many trillion. Excess reserves go up. And when excess reserves go up, the money multiplier falls. So when reserves go up, the multiplier falls. And the product here of H times M, H times the multiplier, didn't have a very big impact on the money supply, particularly on M1. So if you look at a graph of M1, it doesn't go up very much, even though there was this massive increase in H. And that's because this money multiplier is so unstable. It moves around when any of these things change. And for that reason, it's hard to use this model as a good model to explain what's going to happen to the money supply over time. So we'll do that in some other way later on. But so if you're trying to figure out what's going to happen to the money supply, you have to not only look at what's happening with open market operations, but what's happening to currency holdings. I mean, a lot of people started holding more currency because they got afraid. Oh, we need to get out of financial assets and hold either demand deposits or currency. Excess reserves held by the banks went way up. The reserve requirement hardly changes, but for both of those reasons, when currency holdings go up, the multiplier goes down. And in particular, for the financial crisis, when excess reserves go up, the multiplier goes down. And so just because H goes up, if all of that goes into excess reserves, the money multiplier is essentially going to go down to match, and you're not going to get much of a change in the money supply. So the effect of all of those massive open market operations on the money supply wasn't as big as people thought it would be for this reason, and so we didn't get as much inflation as some people predicted. Now let's try to explain this money multiplier a little more. Why is it that, say, if you do a $100 open market operation, you end up with more than $100 in money, assuming the multiplier doesn't change? So we're going to hold lots of things constant as we do this. So let's let the Fed, let's explain this by just going through an example. Let the Fed purchase 100 in bonds from the public and let reserve requirements, the amount of checking accounts that the Fed has to hold inside, the percentage that the Fed has to hold of required reserves for every dollar in checking accounts be 10%. So if you put $1 into your checking account, the Fed has to put 10 cents into the safe or give it to the central bank, and it can loan out the rest. That other 90 cents could be used for loans. Now, so it purchased $100 in bonds. Generally what it does is it says, you give me my bond, you give me your bond, here's a check for $100 that you can go put in the bank. So the second thing that happens is the change in demand deposits is 100. Because when the person puts that check in the bank, puts 100 check from Fed in the bank. The change in demand deposits is 100. Now what does the bank have to do? The bank, because of the 10% reserve requirement, puts 10 into required reserves, and 90 goes to loans. See that? So that the loans would be 90. Now what happens to these loans? People don't usually take out loans, they hardly ever do it, just to sit on the money, as they put it in the cookie jar at home or hidden in the mattress or something like that. The reason they take a loan out is because they want to buy something. So let's say that the loan is used to purchase 90 in goods. Maybe this is 90,000 or so. I didn't really say what the units are here. It doesn't make any difference. And nice numbering. This is one of those typos I was talking about. I caught that one. What does the store do then? The store takes that $90. So you went to the bank, took out 90, and you got your loan. They usually just put it in your checking account. You could either, let's make it simple. It wouldn't matter if you wrote a check. The story is just slightly more complicated. Let's just have the person then take that $90 loan in cash, go to the store, and spend that cash. The store, at the end of the day, let me come out here, I'm running out of room. So the store, I guess that's 5, at the end of the day or week or whatever period it is, puts that 90 into checking account at the bank. Okay, now we've got a change in demand deposits of 90. Already, the total change in demand deposits at this point is 100. That's the size of the open market operation, plus 90. Now remember that M is currency plus demand deposits. Already, this has gone up by 190. So the change in the money supply is already bigger than the open market operation. And we're not done yet, because this process then repeats. The next thing that happens is the bank just got a $90 demand deposit. The bank has to put 10% of that, $9, into the safe as required reserves, and it can loan out the 81 in loans. That loan is spent, and the store puts in bank, just like before. And so at this point, the change in demand deposits. So now we get a change in demand deposits of 81. We've got another change to add on here. Notice each number is getting smaller. That'll keep happening. What's the bank have to do? It has to put 810 into required reserves. 7290 can go into loans. This goes into another bank, a store, it's spent. The store puts it into their checking account. And the change in demand deposits, again, is 7290. And it continues. So if we wanted to add up from this the total change in demand deposits, what would we see? The total change in demand deposits is, there's no change in currency in this model yet. I'll talk about that in a second. The total change in demand deposits is the same as the change in M. So the change in M for this model is the change in demand deposits. And so far, that's 100 plus 90 plus 81 plus 7290. And it would just go on and on and on. Well, let's rewrite that as 1 plus 0.9 plus 0.9 squared plus 0.9 cubed, and so on, times 100. 100, 90, 81, 7290, and so on. We've seen this before. This is a geometric series, a power series. So this is 1 over 1 minus 0.9 is what those all sum up to, times 100, or it's 1 over 0.1 times 100. Yeah? Yes. Now, let's generalize this a little bit. What is that 0.1? Well, that 0.1 is the reserve requirement. So if we want the change in M here, it's 1 over the reserve requirement times, and what's that 100? That's the size of the open market operation. Technically, what that turns out to be is the change in H. It's the size of the open market operation is the change in reserves. I didn't do it, but if I were to add up all the required reserves, remember it was 10 plus, here they had 10 plus 9 plus 8, 10 plus whatever it would be here, 729, and I add all those up, I'd get 100. The total change in reserves, in required reserves, would be 100. So the reserves go up by 100. That's the change in H. Remember, H is C plus R. The change in R is 100. But this is just, to make it simple, this is just the size of the open market operation, which was 100. Okay? So there's our formula. This is the multiplier. The change, if we generalize it even more, this is in changes. It says M equals 1 over the reserve requirement times H. Yeah. For you calculus people, we basically integrated. And this is the multiplier. So clearly it depends, as we said there were 3 things: currency holdings, excess reserves, and required reserves. So far, I've made the model simple. There are no excess reserves, and I didn't let currency change. But so in this case, the multiplier just went over the reserve requirement. As the reserve requirement goes up, the multiplier would go down. So if at each step, I made people hold 20% instead of 10%, if I made banks hold 20% instead of 10%, the multiplier would be smaller because we would get 100, the change in demand deposits, the change in M would be 100 plus, now the second bank would be 80 plus 64, and so on, because you'd have to hold 20% against this. So only 80 would be lent out and 20 would go in the bank. Before, this number was 90. This number was 81. So the total change in the money supply would be less. Another way of saying that is the multiplier is smaller. And so if we make people hold more money in their checking account, or if we make banks hold more required reserves against checking accounts, the multiplier goes down because they're lending out less at each step. So the amount that finds its way back into the bank each time has to be less. Okay? Well, that leads us right into excess reserves. Because this is the same thing that would happen is if required reserves were 10%, and banks voluntarily hold excess reserves of 10%. Total reserves would still be 20%. So we do a $100 open market operation. We write this person a check for $100, take their bonds. They put that check in the bank. The bank has to put $10 into reserves, and it voluntarily holds another 10 as excess reserves, and it only loans out 80. Then that loan is spent. Store puts it in the bank, and then it goes up by 80. And now, instead of just holding $8 in reserves like they're required to do, they're going to hold another 10%, 16. So what's left over for loans is 64. That goes to the store and then back to the bank, and so on. So the total sum has to be smaller. In fact, the reserve requirement, the multiplier in that case, changes in a very simple way. In that case, M is 1 over required reserves plus excess reserves. These are percentages times H. So this is what we were talking about during the financial crisis. H was going way up, but so was the ER term. And so the multiplier was going down at the same time. So the product wasn't changing that much because banks held so much inside. Now, the other thing that can happen is currency holdings. In this case, the formula is 1 plus, do I really want to, I'll tell you. It's 1 plus C over the reserve requirement plus excess reserve plus C, where C is the ratio of currency to demand deposits. So again, the formula gets a little more complicated once we allow currency holdings. And when we allow currency holdings to go up, the multiplier goes down. That's easy to see. So let's do the $100 open market operation. Pays with the $100 check. I'm doing exactly the same. That causes, in the old model, that caused a change in demand deposits equal to 100. $10 goes into required reserves. $90 goes to loans. This is spent at the store. And we had the store put the full amount. Store puts the whole 90 into the bank. And so we had as demand deposits. So the change in demand deposits was this 100 plus the 90 on the second step. But notice something. Suppose this person who took out the loan kept $10 as, let's make it $10 in currency, and they only spent 80. So there's a currency leakage. So you gave them a $90 loan, but they kept $10 in their pocket, and they only spent 80 at the store. Then only 80 would be deposited as a demand deposit, and then the change in demand deposits would be 100 plus 80 instead of 100 plus 90. So the change in the money supply is going to be less. The multiplier is less. Or the store could decide, oh, we need more cash in our cash registers because we don't have enough. So that person just spent $90 at my store. Instead of putting the whole 90 in the bank today, I'm only going to put 80 in the bank, and I'm going to keep $10 of cash in the cash register. Then again, the change in demand deposits wouldn't be 100 plus 90, it'd be 100 plus 80. And so at every step, as long as people hold currency, that's a leakage from this, and you're going to end up with a smaller total change in demand deposits and a smaller multiplier. So 3 things. When either reserve requirements, excess reserves, or currency holdings go up, the money multiplier goes down. And if you want to read pages 73 to 81, I'm not going to ask you any questions about it. It explains all the algebra behind this. Okay, cool. Okay, now let's look at this thing I was talking about earlier, which is how bond prices and bond yields are related. So we've been claiming that the price of bonds and the interest rate are inversely related. How can we see that analytically? Or intuitively, or analytically too. Let's take a really simple example just to, the book goes into a lot more detail. I'm just going to use a simple example to make the point. I don't think we need to do as much detail as they do to understand this, but you're gonna buy a bond, and the bond pays $100 in a year. A year from today, you take that bond somewhere, and they give you $100 for it, depending on who you bought it from. The price today is PB. So the yield, the interest rate on that bond, this is how interest rates are determined, is the 100 that you paid minus the price of the bond over the price of the bond. So for instance, suppose PB equals 80. That's your investment. So you put up $80 today and buy this bond. A year from now, you get $100. So you made 20 on an investment of 80. So this would be 20 over 80 equals 25%. You'd make 25% on that investment of $80 if you got $20 in return. So this formula right here gives us the price of a bond that just held for a year. You could generalize this to 5 years, 10 years, 2 years, any period at all you want, but that's the basic formula, something along those lines. Now, if you rearrange that formula, actually, let me just do it. It's pretty easy. So we said that the interest rate is 100 minus PB over PB. That is, multiply that times that. That's I times PB. Bring that over there. Plus PB equals 100. So PB equals the 100 over 1 plus I. Those of you who've had a lot of finance classes or other classes will recognize this as the present value formula is the sum from I equals 0 to n, where n is the number of periods you hold it. Here n is just 1 of the return at each period. I mean, let me use something other than I here, since I is interested. The return at period j over 1 plus I, the interest rate, to the j power. Okay, that's a generalization of this. I'm not going to care about it. This is fine. So the point then is that if the interest rate goes up, just from this formula, what has to happen? The price of bonds has to go down. So whenever the interest rate goes up, the price of bonds go down. Another way to think of that is from the original intuition. If we pay less and get $100 a year from now, our yield is higher. So the less we pay for the bond, the smaller the price of the bond, because it promises 100 no matter what, the bigger the yield's going to be. So as the price of bonds goes down, the interest rate of the yield has to go up. It's that simple. All right. What else? One last thing we can talk about. When the Fed actually does this, so let's go back to our money demand, money supply model for a moment. Here's the money supply. Here's the money demand. This is M, and this is I. The Fed has to make a choice between a money target and an interest rate target. It has to say, do I want to target interest rates or do I want to target the money supply? Because there's no way it can possibly target both. Let's suppose you had a money target and an interest rate target. So these are the values you want M and I to be. And let's suppose for some reason, maybe PY goes up, the money demand curve shifts out from MD0 to MD1. Now, at this point, you're at your money target still, but you've missed your interest rate target. And if you want to go back to your interest rate target, what do you have to do? Well, you'd have to increase the money supply out to here to hit your interest rate target, because now we'd be at this point. So you're either at this point, which only gets one of your targets, the M target, but it abandons the I target, or you're at this point, which hits your I target, but abandons your M target, and anywhere in between, or anywhere else, you'd miss both targets. And so there's no way that the Fed can simultaneously hit both a money target and an interest rate target all the time. So it has to choose one of the two, and what it does these days is it has chosen an interest rate target, that federal funds rate that we talked about earlier. So what the Fed will do is here's M and here's I. Let's say they're at target right now. Here's the money supply. And they're at their initial interest rate target. Then the Federal Open Market Committee meets and says, uh-oh, looks like the economy is getting weak in the future. We're going to have to lower interest rates. So let's lower our target interest rate to I1. What the Federal Open Market Committee will do, those are the people who set monetary policy. It's the Board of Governors at the Fed plus 5 of the 12 regional bank presidents, and those 5 positions rotate. 4 of the 5 rotate. The New York Fed's always on it. Anyway, details you probably don't need. What the FOMC will do is tell the New York Fed, conduct open market operations, begin buying bonds until the interest rate falls to our new target. So the New York Fed will begin open market operations. So it'll do the first one, like, oh, our interest rate isn't low enough yet. We need to go further and further. And they'll keep doing open market operations until they hit the new target. So they'll move the money supply from M0 to M1. And that'll be the end of it. And so presently the Fed conducts uses an interest rate target. Now, one thing that could happen is that, man, these pens must be writing too much. One thing that could happen, let me write the money demand curve so it hits the horizontal axis at some point. So here, remember, wealth is M plus B. If the interest rate gets low enough, you hold no money, no bonds, and all money. Is that on there? Barely. This is I and M. Hey, I finally found a pen. Here's where they're holding all wealth is held as money and none is held as bonds. And so beyond that, there's no reason to hold anything. So during the financial crisis, as the Fed began increasing the money supply, at first what was happening is the interest rate was falling. So it went from over 5% in the summer of 2007 and quickly fell to 0. Didn't take too long for the Fed to get all the way down to 0. So they kept increasing the money supply until the interest rate hit 0. So initially, the interest rate was falling. The interest rate's the price of money. We had what we might call price easing, because the price was easing, it was getting lower. Then, once the money supply had gone up to this point, any further increases in the money supply could not affect the interest rate at all, because it was at what's called the zero bound, zero lower bound, which is approximately 0. It turned out to be more like 0.25% for technical reasons. I don't want to get into that, but let's just think of it as 0. It's a 0 lower bound. After that, we had what we call quantity easing. You couldn't decrease the price anymore. There was no more price easing, but you could increase the quantity of reserves out there, and that's what we might think of as quantitative easing. Now, there's a better model to do this with, a model of bank reserves rather than the money supply. I'll come back to that later, but essentially, that's what happened during the financial crisis, was that reserves went up so much that interest rates went down to 0, and then they couldn't fall anymore. Okay, well, in Chapter 3, we did the goods market. Chapter 4, we did the money market. What we want to do next, and that'll be in Chapter 5 on the next video, is put these all together into a single model where we have both the money market and the goods market integrated into a single diagram. And that's something called the ISLM curve, and we'll do that in Chapter 5. Thanks.